Let's talk about probability. Probably
You're so funny.
one of the least actually understood mathematical concepts. Okay? In fact, most people are really bad at probability. All right. So probability is all about randomness, and we talk about randomness being the result of a chance process. So as we talk about probability, especially today, what I want you guys to really start trying to think through is, how do you describe what probability is without using the following words? You're going to have some chances to think through this, okay? Without using the word chance, likelihood, odds, what is probability? And before we even really ask you guys to start thinking this through, we're going to do a little activity, okay? So, imagine Coca-Cola is running this new promotion that if you like go to Speedway or something, or the vending machine, you buy a bottle of pop, you twist off the cap, and underneath the cap it either says, hey, you win, and if you win, you can turn in that cap for a free bottle of pop. Cool? Or it's going to say, oh, better luck next time, or try again later, or something like that, okay? And Coca-Cola is telling you, they're making the claim that 1 in 6 wins. Everybody good? Basic premise. All right. Now, you and 6 friends decide to walk over to the Speedway over there, and I'll buy a bottle of Coke. Cool? Or a Coca-Cola product. So maybe Sprite, maybe vitamin water, whatever it is you might drink. Okay? And how many people is that? 7. So of those 7 people, so I'm going to say n equals 7. How many would you expect to win?
1.
1.
And like point something. 1 or 2.
1. If I say 1, maybe 2, because I feel like it's probably going to be 1, right? But it turns out that 3 people win. So 3 out of 7 wins. Guys, 3 out of 7 is, I think it's 42%.
You want me to check?
Sure, but I know it's 42%.
Oh.
Am I close?
Yeah, 43.
43. 0.42 something?
42.8.
There, I said 0.428. Duh. Is everybody okay? I know I'm ridiculous. I'll get over it at some point in my life.
I am too. You're allowed to be a little bit ridiculous.
I'm sorry?
You're allowed to be a little bit ridiculous.
Well, I would imagine I'll be a lot of bit ridiculous before we're done with this example. Okay, so given this situation, I would say we have 2 kind of competing hypotheses going on, okay? Does anybody want to guess one of my 2 competing hypotheses here?
There might have just been more when anyone's closer to the front. Random.
Well, so we're gonna assume it's random each one.
Yeah.
I have this over here. Thanks, Ethan. Okay. So what are our given hypotheses? Lucky. Or the probability of winning is actually bigger than 1 out of 6. Is it? Because that's possible, right? I don't know why they would lie in that direction, but it's possible. Okay? Or maybe the mechanism that's choosing which bottles win, right? Like they probably have a random chance machine. Maybe there's something wrong with it, something like that. Okay? So the question becomes, how do we decide which of these 2 hypotheses is correct? Oh, we're out of money.
Roll a dice.
I mean, what does that tell you? Here, I got one right here. That's weird. You said roll a dice. It came up 6. So which of these hypotheses is correct?
I was just honestly looking at
You were cheating. You were looking ahead. I see how it is.
Yeah, I was.
Okay. So, in the statistical world, both of these could always be possible, yes? Okay. Is it possible that this group, you and your friends, are just a lucky group of people? Sure. Or is it possible that the probability of winning is actually greater than 1/6? Yeah. So what we are going to do is use probability to make a decision. Not this probability, but just probability in general. Okay? So what if we took this dice, we rolled it, and we said, hey, if the dice lands on a 1, that person has won. Get it? I told you it was going to be slightly more ridiculous. A 1 is a win. Get it? Okay? So if I wanted to model uncapping 1, I could do, oh, I rolled a 2. Did I win? No. And that models one person opening a can of soda. Cool? Well, how would we do modeling 7 people opening a can of soda?
7 people.
Or I roll 7 die. Does this make sense? I just need you to tell me how many people won.
Oh, we don't count that at our.
1. All right, so guys, on our trial, only one person won. Is that enough to decide that 3 is impossible?
No.
No. So we would need lots of trials of this, yeah? Huh. You know what I have? I have lots of dice and lots of dice rollers. You with me? So if I give each of you 7 dice, can we kind of go through this little thought experiment?
I appreciate the diversity of your diet.
Thank you. This is what happens when you...
Is it effective that they're different sizes? Whoa, look how tiny these numbers are, Henley.
You mean dots?
I got one.
Okay, it's
This
weird
one
though, because I got
probably 3 6s too. And 3
they're
3s.
not freakishly small.
You got 3 6s.
Look at that.
I had 1 winner.
Big difference. Okay. Are we waiting for you to tell us, Cinderella?
I just want to get them hashed out. Would be great.
One was a winner?
Oh my god. 1, 2, 3, 4, 5 winners. And the other 2 were 5.
3 winners.
What is this?
Do these have a 1 on them? I think the blanket's a 6. Yeah, you're so right, girl. So I had 9. And I had 3.
Okay. So here's the deal. If we each do this 9 times, we'll have 99 values.
Are we doing it 9 times?
Yeah. So here's what I'm gonna have you guys do. Everybody's gonna do it 9 times, and each time just write down your number of winners. Okay? And then at the end, we'll go around and make a dot plot of everybody. Okay? And I'll do one time. It's like set up said dot plot.
I love this. Yeah.
Yeah, because the only thing together is weaker and I'm not gonna win.
Where did it go? Nico, is there a dial by your foot?
Yes. Yeah, I can see it. It's on my side of your backpack.
What number does it say?
1.
I think so.
I did. She said, I'm not sure because, and then stopped talking.
I love when she does that.
Valid.
What? When was before?
School starting.
Okay.
This makes the situation is stressful.
Oh my god.
I have room to love Mr. McCarthy's ability to be scheduled.
Yesterday was a whole week of minutes buying pizza slices while they were getting on.
All right, we ready to start reporting out? To report out, we're going to play Pass the iPad.
Yay! Oh my gosh.
And just put a dot for your points.
All of the points?
Yep. If you need to start making 2 stacks. Guys, I would imagine we're going to run into a position where we might make several stacks on the one.
Yeah.
Because we'll have some space issues. That's okay. And then just pass the iPad to the person next to you and around, and you know.
Next semester.
Yeah.
So, if we were to hypothetically have a midterm, is it over the whole semester? Or will it
Yes.
just be, okay. Okay.
For sure. If we're gonna do it, it'll be.
Yeah. And it's this class, right, that it like replaces a grade or no? What if you don't want a grade to be, what if you,
Then there's no consequence. All it is you get the experience.
oh, okay. Is it?
It can only help your grade.
It can't hurt.
It can't hurt what you've already done.
Cool.
And is our final the AP exam? Or do we have a
No.
final?
You'll have a final, but it'll be similar experience.
Okay.
And then you'll take it like pretty much right after spring break. And the idea being,
To prepare.
it will be very informative. I'm gonna have you guys take that and then gather some data from you guys on what you want from me after you've gone through said experience. Where do you think we should focus our energies to review for the AP exam?
Okay. Okay.
Like, you guys will have a lot of control over what that AP review looks like, and it could be like,
How are
oh,
we supposed to fit everything?
We will. It'll be fine, because like Dylan's gonna start a second pile around the ones.
Okay.
But it'll be the same thing where if you guys want me to count it, I will. If you don't want me to count it, I won't.
And if we don't have a midterm, will it be like
We might still have one after winter break.
after winter break? And
Yeah, just because I genuinely value the experience.
yeah.
So the will it replace a grade becomes a little bit murkier, though I guess you could hold on to it for third or fourth quarter. I'll probably say third quarter if that's how it ends up shaking out timeline wise, because we do have less time because of some of there's the longer spring break stuff, yeah, or longer winter break stuff.
Okay. Okay. Would we have a unit 4 test like?
We're doing 2 unit 4 tests.
Okay. Are they pretty close to break?
No, one of them we'll probably get through. One of them at the beginning in about 2 weeks. And then the other one will be about 3 weeks from now. And then the question is whether or not we can get it finishing at 5. And how I want to do, like, that'll be the. Never did.
Thank you.
Thank you, Florence. Or Dylan. Or Jack. I'm sorry. I was on my phone.
Close
I
call.
wasn't looking. Let's see what today is. Poetry analysis. That makes me want to cry.
Wow. 1, 2, 3.
Okay.
Wow, my dog is really small.
1, 2, 3 ones. Whoa. Okay. 3, 4 twos. And then 1, 3, 1, 4. Oh shoot.
Alright. So, do we just.
Maria, why did we both go out so
That's annoying.
That makes me sad. That's okay.
That was a bad moment. What just happened?
Oh,
Okay, hold on. I think I accidentally tapped it.
Who?
I just don't have a costume. What? That is horrible. I don't know what you mean by that. Sorry.
Okay, so 2. Let's do it.
Your parents would kill you.
I would literally be dead on the streets. So.
We're all gonna be traumatized.
Not really. He would go as like a nun or something. Like I just feel like that's something wrong with it. No, stop. And
I have the most unsteady hands in the game, bro. I mean 5.
That's a 5.
So,
I think Julie.
I got 5, yeah.
It's not gonna be real.
She cheated.
I did not. Oh, no, it was only one.
Thanks, boss. I mean, here. 30 seconds. Wait, we said it last time, like 11 to 12 hours. Interesting.
I don't know. I'm not leaving off my birthday though.
Wait, why are you on for New Year's?
No.
Okay, because I won't be here the 13th through the 30th. Like, 13th through the 30th.
So I'm gonna see you for 2 days.
Basically. Well, actually, I'll be here the 20th.
Where are you going again?
13th through the 20th.
I'm gonna buy a
On
new
your
job.
to Paris.
Yeah.
What?
Oh,
And then visit and
Build
stuff
it up.
and see your jacket. But then coming home, then like Christmas, then I'm with my grandma. Come back for New Year's.
Pretty good.
Sure. That was
And I'll be back.
fun.
All right, y'all.
It's crazy when I was at Disney.
That sounds fun.
All right, so let's start making our conclusions. Hey, when you guys rolled the dice, which of the 2 hypotheses was true? The lucky hypothesis, right? Because when you rolled the dice, the probability was still 1/6, right? So what we want to do is say, well, what is the probability that we could win, that you could get 3 winners by chance? That's what we just kind of started to figure out. And so what we would say, well, we set this up so that we'd have 100 total trials to make this nice and easy. Okay? So if I wanted to know how many of those trials were 3 or higher, I could just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, so we could approximate that at 15%. And the probability is the approximation. Okay, so the probability of getting the number of wins greater than or equal to 3 was approximately 15 out of 100, which is 15%. How would you describe 15%? Unlikely? Reasonably likely? Is that enough for us to rule out that you and your friends just got lucky when you did this?
what is lucky?
You guys tell me.
I mean, if it's
Did it happen enough that you're like, oh yeah, it could totally have happened by chance?
Yeah.
How unlikely does that need to be? Usually we use 5% is our general rule of thumb for something to be considered like super unlikely. Super unlikely, okay? And if we did this again, would we get the same results?
No, probably similar.
Similar to, but not perfectly the same. Is everybody good?
Mm-hmm.
Now, what if I did this 1,000 times and then 1,000 times and then 1,000 times? Would our results resemble each other a whole lot more?
Mm-hmm.
Would you guys hate me if I made you do that? We're not going to do that. We're not going to do that.
I mean, rolling dice for an hour and a half is not the worst thing if you ask us to do.
I beg to differ.
I think there's worse things.
There's definitely worse things I could make you guys do.
The sound would just get annoying, that's
The,
all.
the sound gets really annoying. I've done probability trials. It's the worst. It is actually a really abrasive sound, the dice hitting the tables.
Earmuffs.
Yeah, you just listen to some music while you do it.
Try to ignore the clattering outside.
It's a lot.
Class listens to music while doing it.
See your face crazy.
See who storms out first.
All right. So, probability is not easy. The first thing I'm going to say to you is probability is actually really, really challenging. Because what happens is probability is a number that describes uncertainty. Right? The problem with chance events is we don't know what's going to happen. That's also what makes them useful in sampling, right? And some probabilities are really hard to estimate. Like right now, if I were to just have said to you, what is the probability of getting 3 out of 7 people who win in this scenario without doing this simulation, this would have felt really, really challenging. So the first part of probability is that simulation is a good way to estimate a probability. It won't get us our exact answer, but it's a great estimator. Okay? So, to create a simulation, you are going to kind of follow this process. And you can use a simulation to estimate probabilities. Now, maybe 10 years ago, there was a probability question on the AP exam that the College Board, that kids didn't know how to do. By the way, there will be a probability question on the AP, like a probability free response. There will be a free response that's probability. Okay? And so what kids did is they used a random number generator on their calculator to run a simulation. And it was not how the College Board wanted them to do it, but it was considered, because they described the process well, they got full credit for the question, even though they didn't know the statistics that they were supposed to know. Because they found a way around. Does that make sense? Okay. Now, to build a simulation, you are going to start with a question. Our question is, what's the probability of 3 out of 7 winners if the probability of winning is equal to 1 out of 6? Because rolling a die is really great for 1 out of 6. All right. Then what did we do? I rolled 7 dice, right? And I said, guys, how many winners did we have?
Just want to say good morning. I haven't seen you yet today.
No, we popped in and I made fun of you for showing the Taylor Swift video.
Oh, I didn't hear you making fun of me.
Oh, it's possible I made fun of you.
That's fine. I will show the Taylor Swift video all day. Visual came out today, you guys, just so you know. Okay, good morning.
Oh, hey. Then we rolled 7 dice and used that to make sense of like 1 repetition. And then what happened? We repeated that process 100 times. And the probability of a win we found out to be approximately 15 out of 100. See? Wasn't that fun? And we answered our question that way. Now, eventually we're going to, at the very beginning of the second half of Unit 4, I will actually teach you guys how to calculate that probability, not as a simulation, not as an approximation, but the actual probability. We're not there yet. All right, now, let's talk about a different way we can use a simulation that might make things a little bit easier, this time using a random number generator. Could we have used a random number generator here? Yeah,
Between 1 and 6.
Pick a value.
between 1 and 6, and then we would generate 7 of those values and count how many were 1. But before we had to assign 1 to winning, right? That was part of it. Okay? Is we starting to get a feel for what this looks like? All right. So now, suppose I want to take a simple random sample of 6 people from a group of 60 seniors, 30 juniors, and I choose a group that has 4 juniors and 2 seniors. Is that a problem for my sample?
Yeah, because the groups are not like proportionate to the total population.
I'm going to say the subsets in the sample are not proportional to the subsets in the population.
What's a good definition for subset?
Set from a larger set.
Okay.
Okay. Okay, so my next question. What's the probability that could happen? Because if it's reasonably likely that it could happen by chance, then we're not going to say the sampling process is flawed. We're going to say, hey, this was a chance occurrence. Okay, that still might say, hey, maybe we'll do a stratified sample in the future, but let's see just in general, was there something wrong with the randomization? All we have to do is say, well, what's the probability that happens? Okay. So, how could we use a random digit generator to assign picking a student from this group? From a sampling design, what would we do? Can someone describe how we would get a simple random sample of 6 people from 90 students?
You give each student a number.
Okay, assign each
One a number.
student a number between 1 and 100, okay? Or, I'm sorry, between 1 and 90. Okay, now, if I want to run the simulation, I'm going to do this. Let 1 through 60 represent seniors. And 61 through 90 represent juniors. Does everybody understand why I did that? All right, after we assign a number, we would randomly generate 6 unique numbers, yes? Now, what are we interested in this case? Well, so the question we're trying to ask is get a sample with 4. Oh man, I didn't mean to do that. Get a sample with 4 or more juniors. So what do we need to count after we generate these 6 digits? We need to figure out how many of them are juniors. Okay, so from here, what we're going to do is record the number of juniors, and then in parentheses I'm going to say, or in other words, the number of digits between and then 61 to 90 that were generated. Is this okay? We're going to get through this much, and then we'll take a break, okay? Instead, all right, so instead, maybe I want to make sure I get I've already got all these kids' names in a bag, right? So maybe instead of just randomly selecting out 6 names, maybe I'm just going to keep drawing until I get 4 seniors and 2 juniors, so that I have that nice stratified sample. Is this okay? All right, so all of a sudden, my question of interest is going to shift to how many times do I need to draw? So now we're not just going to do 6 at a time. We're going to do them 1 at a time until we get the juniors necessary, the number of juniors and the number of seniors. Okay, so we're still going to let 1 through 60 equal seniors, and 61 through 90 equal juniors. That's just assigning what's what, okay? And we're going to draw use the random number generator to get numbers between 1 through 90, drawing 1 at a time. Hey, by the way, what's wrong with my answer rate so far? You need to get unique numbers. Yeah. Okay. So I'm going to generate a number. Let's go ahead and say that the first number I generate is 58. That is a senior. Okay. My next one is a 41. My next one is an 88. My next one is a 2. My next one is a 3. My next one is a 9. Senior. So for those first 6 people, do I have the sample I need? No, so I'm going to keep going. My next one is a 31. Senior. My next one is a 78. Junior. Now do I have the sample I need? Yeah. So my sample would consist of this one, this one, this one, this one, and this one. We'd ignore those seniors that we already generated. But how many trials, how many times did I have to draw a name out of a hat? 8 times. Does that make sense? Okay? So we're going to draw one at a time. Keep drawing until we have 4 numbers between 1 and 60 and 2 numbers between 61 to 90. Record the number of trials. And then instead of trials, I'm going to say generated numbers. Everybody good? All right, so now if I said the most likely way you are going to be given something from a simulation is I'm going to have one described to you, and then I'm going to say, here are the results. So down here is the results of doing 50 trials of what we just described. Okay? And if we look at this, if I said, what is the probability? We want to do 10 or more. So what is the probability that the draws are greater than or equal to 10? And all we have to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of the 50 trials, which is 22%. Reasonably likely to occur by chance. And this is a good spot to take 5.